Let's talk about partial fractions a little bit. I did some stuff in class one day where I had, I think it was something like this. And when we're integrating stuff, we know it's helpful if we can break things up into two fractions, right? You know from Calc 2 that if they have a linear denominator, that's a logarithm. If it's quadratic, it might be something like an arctan or an arcsine or arccosine. So this we don't know how to do, but if we can break it up into pieces, it's easier. So what I was suggesting is that for sometimes it's easiest just to guess. And so we certainly know what the denominators are going to be. But the question is, what are the numerators, and is it plus or minus? And usually you would, you write A and you write B. The long way of doing it, A and B and plus, and then you cross multiply, you have an equation, you plug some things in, blah, blah, blah. And that's great, except it can be a bit slow. Sometimes you have to do it. But if it's simple like this, just try doing 1 and see what happens. Now in this case, it's not bad. If you cross multiply, you'll get P minus 1 plus P. Actually, this one's a little trickier. Over P minus 1. Now this doesn't quite work, right? Because we end up with 2P minus 1. We don't want the P's to add, want them to subtract. Oh, maybe this should have been subtraction. What would it be then? You'd have P minus 1 minus minus P, right? Because P times 1. Sorry there, I get caught up. Over P minus 1. Now the P's cancel, and you get a minus 1 over P minus 1. Now that's not quite the same, right? That's true, right? So you can either throw a minus sign in front of this, now it will be, or you can flop the signs. So minus 1 over P plus 1 over P minus 1. And you can check this. That would give you a minus P minus 1 plus P over P minus 1, which is a minus P plus 1 plus P over P minus 1. Those cancel. Now, a good argument here is, well, Kevin, that took me just as long as it would have the other way. Yes, except this isn't how I do it ordinarily. This is just an explanation. So let's try a couple more. Suppose I had 3 over 2P minus 1. At some point, it does become too complicated, but let's see what happens here. So I know I'm going to have, well, actually, this is a bad example because I would just factor out the 3 and the 2. I would just do this, and then I would focus on the same fraction. So that number is not very helpful. That's a bad example. It's not any harder. Let's do 3 over P minus 2. That's a little different. So what would I do? Well, I know that my denominators are going to be this. And again, I always just start with this in my head. It's very easy to cross multiply with 1s. This is going to be P minus 2 plus P. That's not going to work. P minus 2 minus P. Oh, great. That's close enough. Right? So I would do 1 minus this, knowing that's going to give me a P minus 2 minus P is minus 2. I just need a minus 1/2 in front. All right. Now, let's pause a moment here. So does this work? This is what I'm claiming. If you recombine these, we'll multiply afterwards. I have a P minus 2 minus P over P minus 2. The P's cancel. I have a minus 2 times a minus 1/2. Yeah, it works. Whatever number I end up left with in the numerator is easy to accommodate. Let's see. What about something like negative 4 P minus 1 P minus 2? Let's see if I can do this one. So P minus 1 p minus 2. Now this minus 4 actually doesn't make any difference at all. What do you mean, Kevin? Well, I mean, you can just factor it. I don't actually have to end up with a total of minus 4 on the top. 1 would be fine. All right. So how do I do this? Well, I'm going to need a minus sign somewhere to subtract one of these p's out. So I could do 1 minus 1. What does that give me? Well, it's going to be p minus 2 minus p minus 1. The p's are going to cancel. Of a minus 2 minus a minus 1, minus 2 plus 1 is negative 1. So I'll end up with a numerator that's negative 1. And that's fine. I started with a negative 4. I just need a 1/4. So the answer is going to be this. If you recombine this, this will equal minus 4 over p minus 1, p minus 2. Now, what am I suggesting here? I'm only suggesting this for some partial fraction decomposition. If I have some p minus 1, p squared plus 1, whatever, 2p minus 3, I'm not going to guess this. That's ridiculous. That's going to be a real pain in the butt. For this, yeah, of course, I would start out with the typical partial fraction decomposition. This is how I would do this one, because this is complicated enough that guessing is going to be just as long as doing this. What I'm suggesting is that if you have something like p plus 1, p minus 4, and any constant up here, you can do it with p's. It's just a little trickier. Again, at some point, the guessing is not faster. But something like this, again, I know I have to have subtraction here. And I can just see it's p minus 4 minus p minus 1 is going to give me a minus 5 in the numerator. So I just need a minus 1/5 out here. So you don't have to ever do this, but I just mention it because this sort of thing happens a fair amount, much more so than complicated ones. The complicated ones do happen, just not as often. So it's easy for you to practice this too, by the way. Pick a number over p plus or minus a number over p plus or minus a number, and then try to do it the quick and dirty way. And you can check your work, because it has to recombine to be the original fraction. So if you're interested, there's a few more examples.